Hello, in this video we continue to explore the MDAnalysis selection language, and specifically we are going to cover the geometrical selections, similarity connectivity selections, and dynamic selections. Geometrical selections allow you to select atoms relative to a different group of atoms. For example, you can select all the atoms within 6 angstroms around your ligand, like we are going to do in this video. We will also select them using different coordinate systems. For example, spherical coordinate systems allows you to select atom within sphere of 6 angstrom radius, and also we have, for example, cylindrical coordinate system similarly, or different layers of these two systems. Similarity and connectivity selections allow you to select atoms with the same properties as some other atoms, or atoms connected to other atoms belonging to some group of atoms. By default, you make static selections, which means they are defined one time per trajectory and they never change. But you can also do dynamic selections by passing through with updating keyword, and this will allow you to select, for example, all the atoms satisfying some geometrical criteria at each frame of your trajectory. As in most cases with molecular dynamics trajectories, only coordinates are changed per frame. Using dynamic selections mostly makes sense only with geometrical criteria. The most popular choice is just to select all the atoms within certain cutoff from your ligand, but you also have different options. For example, you can select all the atoms within sphere zone centered at your group of interest, or within cylindrical zone, again centered at your group of interest. And also you can select all the atoms that lie within, for example, 6 and 4 angstroms of your spherical zone around ligand, or cylindrical zone. So you exclude those that are within 0 to 4 angstroms. If you are not sure how to make this as a selection, you should always check the user guide. Here I skipped a bunch of boring typing, just open the Jupyter notebook on GitHub to see what is written there. Sum up all the options with geometrical selections. You can select all the atoms within distance threshold, within a sphere zone or layer of sphere zone, within cylinder or layer of cylinder. You can also select all atoms around certain point in a 3-dimensional space, or you can slice your system and select all atoms like with coordinates along the axis higher than a certain value, or lower than certain value, or along x or y axis. Then you have a similarity selection, which allows you to select atoms with the same, for example, charge or other physical-chemical property as some other atom. Connectivity selections allow you to select atoms within a specific residue or segment, or for example, all the atoms connected to some other atoms within your system. When you use dynamic selections with select method, it returns updating group of atoms instead of just atom group, which is static. But to actually save different dynamic selections per frame, you need to iterate over your trajectory and manually save each frame as a PDB file, because they contain a different number of atoms, and you can just store them as one trajectory, like TRR or XTC. Let's visualize atoms within 6 angstroms from guanosine 3-phosphate at the first 11 frames of our trajectory. Thank you for your time. Let me know if you have any troubles.